right, here's today's starter. We're going to kind of go through a real-world problem about these airplanes that fly through hurricanes. And, they need to pay attention to what their ground speed is, what their airspeed is, what their directions are, and all that. So here's the problem. We have a research aircraft is flying with an airspeed, that's its velocity compared to the air, of 240 miles per hour. And a heading, that is the direction the airplane is pointed in, of 30 degrees south of east. But it's flying into a hurricane with winds of 110 miles per hour at a direction of 10 degrees west of north. So that's what's given. And we want to find out what is the, I should put vector hats on here. What is the velocity of the plane compared to the air? And what is the velocity of the air in polar coordinates? We got to take what's given and kind of transfer it into a form that we can use. Then we need to convert those polar coordinates into rectangular coordinates, because we can't add those vectors together unless they're in rectangular coordinates. You cannot add vectors together unless they are in rectangular coordinates. And then we want to know what is the speed and direction, that is polar coordinates, of the plane compared to the ground. Okay, so if you're watching the recording, please pause it now and try to pause the video now and work the problem. Okay, so given, I'm going to kind of do this here, given. So north, south, east, west, as I've shown up here. We've got the velocity of the plane compared to the air is equal to 240 miles per hour and 30 degrees south of east. I'll just abbreviate it like that. So this is almost in polar coordinates. I give you a magnitude and direction, and then the velocity of the air is equal to 110 miles per hour at 10 degrees west of north. So I'll just kind of abbreviate it that way. And what are we trying to find? Well, I want V and, let's see, A. And the velocity of the air in polar. And then B, I want them in rectangular. And then C, I want to know what is the velocity of the plane compared to the ground. What is the ground speed? Okay, so let's solve over here. So A, 240, 30 degrees south of east. We're south of east, so that's kind of down like this. Here's east, so I'm going to go 30 degrees south of east. So that would be the velocity of the plane compared to the air is equal to 240 miles per hour at negative 30 degrees. Now the velocity of the air is equal to 110 miles per hour, but it's 10 degrees west of north. So here's north, like right here, and I want to go 10 degrees beyond that, west of that. So that's kind of like that. Well, in polar coordinates, that would be 90 plus this 10. So that would be, 90 plus 10 is 100 degrees. Okay? Did everybody understand that? Everybody get that? Okay. Now for part B, the velocity of the plane compared to the air, well, in rectangular coordinates, you just take 240 times the cosine of negative 30 degrees, 240 times the sine of negative 30 degrees, and of course that's in miles per hour. I'll just put the units outside there. And now I get my calculator out to get my first answer. So 240 times the cosine of negative 30, and I get 207.8. miles per hour. And in the y direction, I go 240 times the sine of negative 30. You have to have that negative in there or you won't, and that's going to be negative 120 miles per hour. So there's that. Now the velocity of the air is equal to 110 miles per hour times the cosine of, well, its angle is 100 degrees. And in the y direction, it's 110 miles per hour times the sine of 100 degrees. Am I on the screen? Okay. So when I do the arithmetic for this, 110 times the cosine of 100 degrees, and I get negative 19.10 miles per hour. And then I'm going to go 110 times the sine of 100 degrees, and I get 108.3. Round that off. So this, now we know how fast it's going in the x direction and how fast it's going in the y direction for both of these vectors. Okay, now I need to add them together, because here's the basic equation for relative velocity problems. Let's do part C right here. The velocity of the plane is equal to the velocity of the plane compared to the air plus the velocity of the air. This really makes intuitive sense. Just imagine you're paddling in some water. If the water's moving, you have to add how fast you're going through the water plus how fast the water's going. But you have to add them as vectors. You might be going against the current or with the current or at an angle to the current. Same thing's true with this airplane and the moving air. So the velocity of the plane is going to be equal to the velocity of the plane compared to the air plus the velocity of the air. I like to line them up vertically like this. And so this in the x, let's see, this is 207.8 miles per hour, negative 120 miles per hour. And then this is negative 19.1 miles per hour. And this is 108.3 miles per hour. So now we're going to figure out what the velocity of the plane is in rectangular coordinates. 207.8 minus 19.1 gives 188.7 miles per hour. And then negative 120 plus 108.3, and I get negative 11.7 miles per hour in the y direction. Well, so now I need to convert this to polar coordinates. So the magnitude is equal to the square root of the x component squared plus the y component squared. That's all going to be in miles per hour. Now, one thing, if you have a negative component, make sure you put the negative within the parentheses here so that when you square it, it becomes a positive. Otherwise, your answer isn't going to make sense. If you get an imaginary number or something weird like that, it's because you're not squaring the negative away. So I'm going to go 188.7 squared plus 11.7 squared equals, and then I'm going to take the square root of that, and I get 189. Miles per hour. Now let's figure out the angle. Is the inverse tangent of the y value over the x value. The units just cancel away, so I'm not going to write them. And so now I go second function tangent. That gives me inverse. Now don't forget the negative. Negative 11.7 divided by 188.7. Now, do I need to add 180 to this, to my inverse tangent? No, because the x component is positive. I'm either in the first or fourth quadrant. My calculator is going to give me the correct answer, which turns out to be a pretty small angle. Negative 3.55 degrees. So now I can write out, okay, the velocity of the plane is equal to 189 miles per. Well, I can do that. I can do it, but miles per. Let's try again. Miles per hour at an angle of negative 3.55 degrees. Or you could say 189 miles per hour, 3.55 degrees south of east. So it's almost flying due east. Not quite though, a little bit south of east. Okay, so that's kind of long, huh? Let me show the whole thing here. There's the whole bloody thing. Pretty long problem. Oh, it didn't focus very good. Okay. So, when you're dealing with relative velocity problems, the velocity of your object equals the velocity of the object in the moving stuff plus the velocity of the moving stuff. Makes sense. But you can only add them together if they are in rectangular coordinates. Remember, vectors, you cannot add them in polar. You have to convert them to rectangular coordinates. Then you can add them, and then once you have the x and y component of your answer, you can use Pythagorean theorem and inverse tangent to get your magnitude and direction of your answer. Any questions on that? Okay. That is all.